Hello, we are group 4 and our project was about building a track, and this is our track with the sorting yard. This is our sorting yard. Our track has 7 switches. This is 1, 2, 3, and then the fourth one is right here at the entrance, and then 5 and 6 and 7.
We decided to choose this layout for our track. It's just one large loop with one side of the loop having a path to go around so that way we can have 2 locomotives going in opposite directions. In order to be efficient in our space, we also decided to put the sorting part in the center of the loop. So the different categories we have are the caboose, the tankers, the tall coal cars, the storage cars, and then the short coal cars. So we also have 5 digital IR sensors that we decided to place on the trees. Each of these are for tracking the position of the train, each at a different location of the track.
So for this project, we have to come up with an idea to be able to display where the train is at the real track. So what we first did is we used a program called AnyRail, and we use it to be able to design this layout that you can see. And then we have to import this picture to Python to be able to code, and we use it on a canvas. This is the code. We imported the picture, then we have to set up the GPIO pins to those sensors, which are these sensors that we explained earlier. And then we also set them up as an input and active pull-up because they act as a logic loop. And then we defined a function which is called train located, and this is with if else statements for each sensor, and when they're gonna turn green when the train passes by on the real track. This is the demo, and then if you put that right in front of the sensor, it turns green, as you can see.
That one works. That one works. That one works. That one's not plugged in. That one works. And that one works.
That one works after it accidentally ran.
Alright, so we needed some way to be able to have the user choose what car that the locomotive picks up from the sorting yard. So I created this GUI. First it pops up this initial conditions window, and it allows you to choose the number of each type of car that starts in the sorting yard, and then we're able to choose the number of cars that start on each locomotive, as well as choosing the position based on the IR sensors of where each locomotive starts. Of course, once I fill these out, I hit start, and it initializes this next window that actually allows us to select what locomotive we're going to have cars queue up for. So if I select an engine, I'm then able to select a car, and it adds it to the queue over here. It shows which engine that the car is queued up to be picked up by. So as you can see, whenever we are out of a certain car type, it blacks out, so that way the user is no longer able to add it to the queue. As you can also see, once the queue becomes full, all of the options black out because they're no longer able to queue up any more cars to be picked up by that engine. Now, of course, I can swap over to the other engine, which the queue is not full, and it allows me to select more cars to add to that.
Since we have to sort the trains, we are using magnets, like these magnets. They are located at each of the categories. Because this is the method we're using to decouple the trains. So when the train goes over the magnet, and it stops and then it pulls away the train, it's gonna decouple.
Couple. Yeah, it is supposed
So now you're just not work now? Yeah. I can,
It's pretty straight. Forward a little bit. Stop. Backward a little bit. Forward a little bit. Hey, let's go, boys!
I did.
So we also designed this traffic light that is to indicate whether a train is safe to pass through an intersection or not. So the way that the way the light is supposed to work is whenever it is clear and both trains are on this side of the loop, then it will turn green for the next locomotive that is able to pass through the intersection. Now, once the locomotive has passed through the intersection, the light will return to red, indicating that it can no longer go through. And of course, once it returns back to the position, the other light that unfortunately we don't have would turn green, allowing the other train to move forward. Unfortunately, we were not able to complete these traffic lights because we ran into some trouble integrating all of the software. Unfortunately, we don't have a demo for those. So we needed some way to be able to identify all of the cars individually, and so that way we could sort them out and pick them up properly. Of course, the obvious choice was to use an RFID tag as well as an RFID reader so that we could read the tags. Each tag has their own individual number associated with it, and then as they pass by the RFID reader, they are read, and the Arduino that is controlling the reader is also controlling the switch tracks over here. And it is able to switch these switch tracks based on what tag is read. And then the train backs it up into the correct location. Now, of course, we have this one track right here that because the solenoid is busted, we had decided to use a micro servo to manually control the switch on the side of the switch track.
Go. Go forward, stop. Go back. Go. Oh, there you go, perfect.
You fixed the not getting a good reading now. It's a nice clean reading every time.
Yeah.
Good. We decided to buy trains that didn't have the decoders inside of them because they were cheaper. For this reason, we have to install the decoder, and for this we have to solder the connections. As you can see in here, they are soldered, and it also included the speaker. After we solder, we reattach the shell to make it look like it was before, or we tried to do that.
Doesn't matter which one is first.